So today I'm going to try to explain a bunch of things. I did a stream a while ago where I tried to explain signals, but then later on I saw the stream that I did and I realized that it was confusing things. And now everything is a lot more clear on my mind. There's a bunch of things that I clarified recently, and I'm going to try to explain everything. But there's a bunch of things to explain, and I might get a bunch of things wrong because I'm still learning. So take everything I say with a grain of salt. And I'm going to follow this list here of topics that I have. And yeah, explain one by one. I did a bunch of things on SkyDraw as well. And then I'm going to show on the code and on SkyDraw. I might forget some things as well because there's a bunch of things to explain. But hopefully I can remember everything. Just gonna wait to see if it's streaming on YouTube. It takes more time. So I'm going to start by showing the editor there. So basically, this is one of the things that I wanted to clarify. So here is where, so each thing you see here is related to a specific scene. And then for each scene, you can add different nodes on the scene. And everything on Godot that shows up on the scene is going to inherit from a base class called object. And then the derived classes of that class are going to be variations of the object that specialize the behavior, let's say, depending on what you want the thing to do, which is going to be a node. So everything essentially is a node inherits from an object. So this is from Godot documentation, the relationship between classes, class hierarchy. So here, for example, if you create, I have a mesh instance 3D that I created. And everything that shows up on the editor is going to be a class, an editor class. So in this case, there is a class that is related to the inspector. And this is the class that is going to be responsible for displaying everything that happens here. And what the class is doing under the hood is just, it's not exactly, but it's as if it's initializing the class mesh instance 3D. And all these attributes, all this stuff you see here is related to those classes. So here is the attributes related to the mesh instance 3D. And then because the mesh instance 3D inherits from geometry instance 3D, you also have those attributes here. And basically you have the class hierarchy here. So it shows everything, all the attributes from all the classes the mesh instance 3D inherits from. So you can change them. And obviously the same on all the other ones. And then if you click on node, this stuff here is all the signals that the node subscribes to, the classes subscribes to. So in this case, mesh instance 3D inherits from node 3D and node and object. So each one of these functions is the events that these nodes have. So here, one of the questions that I had was, when you click here, you can select what kind of mesh is going to be. And this is just a member variable of mesh instance 3D. So in my case, I was selecting sphere mesh, because this is what I want to do. And the way that this works is that on the code here, you can see that you have the mesh member variable, the mesh instance 3D, the mesh inherits from this, which inherits from visual instance 3D, which inherits from node 3D, which inherits from node, which inherits from object eventually. And object is the base class. And this member variable here is a mesh, and a mesh is a primitive mesh. So primitive mesh inherits from mesh. So mesh is the base class. And there's a bunch of different variations of the primitive mesh. And essentially everything that shows up there is one of these classes here that's going to inherit from primitive mesh. And the reason why it's declared as a mesh on the mesh instance 3D is because usually on C++, that's what's going to happen when you have inheritance between classes, because obviously it makes more sense to declare the type as the base class type. And then what C++ is going to do is going to figure out, if you're using one class that derives from mesh, it's going to figure out that the base type is mesh, so it's going to be able to figure that out. And there might be some problems that is talked about in the past, which is object slicing, which basically means that C++ is going to slice some of the functionality of the class, but I'm not 100% sure about that. So yeah, but you can look it up. It's called object slicing. So it can be problematic, but I'm not 100% sure if it is. So this is one of the main questions. I think that explains this. So I'm going to move on to the next topic. So the other most confusing part, just going to close this stuff. So basically there, if you want to do it from code, which is what I'm trying to do, all you have to do is just initialize the mesh instance 3D or whatever node you want to put, and then you change the attributes. You just go into the class, see what attributes the class has. It's usually going to be a base type, and then you have to figure out if that base type is deriving from some other type, which usually is going to be. And then from that type, you figure out how to change the attributes. So here, when you select the mesh, what shows up here on the radius segments, this is going to be related to the sphere mesh, because it inherits, and then each one is obviously going to have their own thing. So if you choose another thing, it's going to be just remember whatever shows up here is going to be the values of the mesh that you can, the primitive mesh that you can change. It's basically just showing the attributes. In this case, is skeleton and surface material, I think. Yeah. So the next thing is the difference between notification and signals. So there's two different things that are related to events on Godot. One is the notification function, and the other is the signal. So a notification is something that allows you to change the behavior of the class inheritance. So throughout this chain here, in this case, I selected mesh instant 3D. You're going to have a class hierarchy, which is the thing that I showed there, which comes from the documentation here, and also the code there, you can see. And each one of these classes is going to have, may or may not have, an implementation of the notification function. And they are cumulative to each other. So there are some points on the rendering cycle where Godot is going to emit an event called notification, and then that event is going to run the function for all the classes that are part of the class hierarchy. So, and that depends on the order you put there, you pass to the function. I'm going to show the function, but I think that the standard order is that the base one has higher priority, which means that first the notification for the object or for the base class is going to run, then it's going to traverse all the way to the whatever class you have. So in this case, it would be mesh instance 3D, and for each one, it calls the notification function of each one. So it's kind of like allowing you to add extra functionality to the class inheritance. This is the point of the notification, but the point of signals is different. So, and this is the part that I was confused in the when I was explaining signals, is that a signal is related to the object instance you have. So for example, here I would have a sphere node, and each one of these sphere nodes on this tree here, which is the sync tree, has its own reference. So the signal is related to the object itself, which would be the sphere node, and then each one of those objects has this class hierarchy here, depending on what kind of node it is. So for each one, if you want to implement a signal, for each object, there might be several notifications that happen. So you can change that way the object. And there might be, and for the signal is more related to the relationship between different instances of different objects. So yeah, that's what was the main confusion that I have. And the reason why I was confused about this is because, and again, I should know this before, but it's because of this macro here. Because when you're stepping over the code, the debugger doesn't go over the functions that are declared inside the macro. So it becomes kind of invisible when you're stepping into or stepping over. And I should have remembered that, but yeah, I didn't. So basically the way that it works is that when you call this macro here inside of a class, you're gonna allow Godot to register this class on the class DB, which is a global class that they have to keep track of all the classes that exist on the project, mainly the objects, and all their methods. And this is going to be used to interface with the scripts as well. So these pretty much are all, it's like you're copy pasting all these functions there on the main, on whatever class you put this macro on. And one of these functions is going to be related to the notification. So here the object class has a function called notification. And this is the function that the debugger steps into. But the debugger doesn't show the functions declared on the macro, share these functions here. Is this function here pretty much? So when you're going over it with the debugger, it's just going to show the function that is called on the object class, which I think is this one. So basically, it's going to be at this point here, but this calls a macro, and I'm going to show later on. This is another confusing part. But basically, in this function here, and on another function from the OS, this is the main iteration, which is the main rendering cycle that is going to happen. So all the functions related to whatever is going to happen in the main loop of the game is going to be here. And this is the first part that it calls. Somewhere inside of this function is going to call a function that traverses through all the nodes of the tree and calls the notification function for each one, which is going to call this function here from the object class, which is the base class. And then this function here is going to call this other function. But the debugger is not going to step into this function because this one is declared on the macro. So if you click here, it doesn't have anything because it's a virtual function. But realistically, when you subscribe the class using GD class, it's going to override the functionality of this on the macro. And then what this function does is the M inherits is the parent of the class. So when you subscribe here, the parent would be the object, and the M class is going to be node. So M class is the current class, and M inherits is the parent class. And then this is the order that I talked about. If you put reversed, it's going to do the other order of importance, which is basically just changing which notification function has more importance or runs first rather than the other ones. So if you don't pass this, then this condition is going to be true, which means that it's going to call the notification for the parent first. So what's going to happen is, let's say you have, as far as I understand now, but I might be wrong about this, but I'm wrong about the order thing, but I might be wrong about which one is which. But basically, so let's say this one is going to be false, so here's going to be true, which means it's going to call for the parents. So in this case, let's say it's node, or let's say it's mesh instance 3D. So what would happen is that it would call from here, and then it would go to the parent, which is this one, and it would traverse recursively until it gets, because each one is going to have the same P reversed, and it's going to call the same function, which is the notification function for each one. So it's going to traverse until it gets to this one. And then once it gets to this one, then it's going to call the notification. And then it's going to go back the stack and call the notification for each one. So it's essentially saying that the order of the notification functions is going to be from the root, which is the base class first. And then the last function, the last notification function that it's going to call is going to be from the higher class. But if you pass the P reverse, then it calls this one first, and then it calls all the other ones. It could be the other way around, but the concept is still the same, pretty much. And this is the thing that is going to determine when it starts calling. So this is the base condition. It just checks to see if the current notification function from the current class is the same as the notification from the parent. And if it is, if it isn't, it calls. So, yeah. Yeah. So basically, inside of this here. So the reason why you can't really see is because this one is going to call another macro, which is the confusing part. So it's this one and the OS one that is going to call. So this one. So it's both this function here at this point and at this point. So those functions are going to call other functions, and then they're going to loop over all the nodes on the sync tree, and they're going to call the notification for all the nodes. And if you go on the notification for the higher classes, maybe I can show on the mesh instance 3D because yeah, essentially they're gonna have like this. So at each point of the rendering cycle here is gonna call this notification function with a different flag, which is gonna determine what kind of step, what is the part of the rendering cycle that it is at. And all of the functions that implement the notification are gonna be in this format where they're gonna use a switch, and depending what kind of thing it is gonna do different things. Which brings me to this macro here as well, because the notification is not called directly on the function. They call this GD virtual call macro, which was the other confusing part that I had, that I didn't understand very well. But this macro here is the main macro that is used as a bridge as well. So this macro just calls this function here. And this is kind of weird, but what this is doing, in C++ you have these two hashtags here, which is called token pasting operator, which is basically gonna do is, let's say the M name is like hello, for example. So when you call this macro with the hello as the name there, it's gonna just replace the whatever you put between tokens there with the thing. So in this case it would be hello, and then call false. So it would be as if you're calling the function like this, in case you pass hello here. And what this is going to do is this is going to be a templated function, so it's just going to pass the value of the template as false. And this va_args here is an environment variable. And what this pretty much says is that it's going to replace whatever arguments the function has. It's going to call with the arguments. This part still, I'm not 100% sure about the va_args, but it's pretty much like this on the conceptual level. So the confusing part is to understand where this function declared. And the way that this function is declared is with a file that is generated at build time. So the Python file that generates this file, because Godot uses scones, so when scones is running, you can put a bunch of Python files based on the functionality of the other Python files. So basically, scones is going to read a file that's called sconstruct, and it's going to look for those files inside of the root of your project, so the working directory of the project. And then it's going to call all the functionality inside of this sconstructs files, which is Python functionality. And then inside of those files, you can call sconstruct in order to call other files in the same way. So here, for example, the main one that runs for Godot is this file here. And then on this file, you can declare sconstruct as well. Sconstruct. Script actually, and what this allows you to do is just pretty much run other files in the same way that sconstruct runs. So in this case, it's adding all these other files to the build. And on these files here, there's a bunch of other. You can add other Python files to add extra functionality to the build. So in this case, so there are other cases there. I think it's this methods here. It has this Python file as well, and then does some functionality, but at some point, it's going to add this other Python file that is this make virtuals. And this file here generates the code for this GD virtual generator file, which this file is going to declare the macro that is being used on this functions here. So this macro here is defined on this file, which is generated at build time through these variables here and through these other functions on the make virtuals Python file. And the reason why I think that they do things like this is because what this allows you to do is not only allows you to implement different, so the main point is to implement virtual functions, but what it allows you to do is to implement functions with different versions of the GD script, for example. So it makes it easier for maintaining versioning of differences in Godot versions and on script versions, as far as I understand. And also to implement a bunch of functions just by tweaking the macro. So basically, the code here is going to be used on build time to generate this file that's going to have the macros. And then these are the macros that are going to be called on these main parts here. And these macros are directly related to the GD script events or signals, because they declare these functions that are going to be called. So in this case, you had there this pattern here, which is basically this function here. So whenever it calls this GD virtual call, so here, for example, would be physics process, and these are the arguments the physics process takes. What this is going to do is going to call this other thing here, and this is going to pretty much replace the macro here. So in this case, it's calling this function here with the arguments that it passed here. That's pretty much what is happening. And what this is going to do is going to check to see if there is a script on the current object that is calling the function. So it's checking to see if the node has a script attached to it. And if it does, it's going to call the function from that script. So these functions here, they work as the interface between the GD script or C# and the C++ code based on this versioning system. So it's all declared based on macros, and that's why it's kind of confusing, because the compiler is not going to directly, or the debugger is not going to directly show because it's declared on macros. And also here, there is some functionality for extensions, which is a GD extension, which works in a similar way to the way that scripts do, which is another thing that I realized. There's a difference between modules and GD extensions. Modules allow you to implement scripting functionality by allowing you to subscribe new classes to the class DB, which is the main class, the global class that is used to keep track of all the classes on Godot. And GD extensions allow you to create a member variable in the object class that is very similar to the way that GD script works. So GD script assigns a script instance class. So the object has this script instance, which is a member variable of the object class. And this is going to be the class that is responsible for creating the bridge between whatever language you have, which is going to be either GDScript or C#, and the object class. So, the bridge happens with signals. And the way that these signals are subscribed is similar to the way that add signals is subscribes normal events to classes. So if you want to call an event, a signal on Godot, you have to subscribe that signal using the add virtual macro. And what the add virtual does is subscribes the signal on the class DB, which is the class that is used to keep track of all the signals that the class has. So you're basically just translating all the information from the class to the class DB. So class DB keeps track of everything that is happening. Now I don't remember. Maybe it's a different name. It's not add virtual, it's add signal. Yeah, add signal. So add signal is the macro that they use for the standard signals. So in this case, it's adding the signal with this name here, which allows the class to subscribe to signals. And the same pattern happens, but in a different way with the signals that are related to the GD script. So if the GD script uses these virtual macros to subscribe everything. Which I just lost here, but it's somewhere here. I do remember that nodes, because it's easier to get by the name here. Yeah, so in this case here, what Godot is doing is using these macros here to subscribe the signals on the node class. And these signals here are the ones that show up on the GD script. So the name here that puts here is different than the name of the normal signal. The name of the normal signal doesn't have the underscore. So this works, the macros work as an interface between the C++ code and the GD script code. So you subscribe. So these are analogous to add signal to normal signals that C++ understands, but it's for GDScript. And these things are going to be called on these parts of the cycle through these macros here. They use, like, you also uses the same macros, or like same kind of macros to do the calls of the events. So in this case, if the class has a script attached, it's going to call from this generator file here. And this is going to check to see the instance. So the GD extension is similar to the script instance, as far as I remember. So which is the thing that I also got it wrong, I think. So it's on the object class. GD extensions is slightly different than using modules. So when you use modules to do scripting on C++, what you're doing is you're creating another class. So it would be like creating another class here as a child of this one to extend functionality of whatever class you're inheriting from. So let's say, for example, I want to add a script to mesh instance 3D. What I would do is create another class, so new mesh, for example. And then I would subscribe this class to class DB using the bind methods function that I showed there and the add signal. Basically, just tell GDB what the type of the class is, and what is all the methods that exist on the class with all their arguments, and then what is all the signals that I want the class to have. So basically, subscribe to class DB. And then I would put whatever new functionality I want the Mesh Instance 3D class to have on this node here. And then from the editor, I would use this node instead of the Mesh Instance 3D. So here, I believe I created the graph. So this is one node, for example, that I created on modules. And so this node here would reflect the node that I created on Brahma to do whatever functionality I want. So that's basically how you do scripting using modules. But that's slightly different than, so you have to use the GD class as well to subscribe, to run the macro and subscribe all the other functions. So the class is subscribed to class DB. But so this is the main function that subscribes everything, all the methods of the class, and you subscribe the signals here, whatever signals you want. And this allows you to extend functionality, which basically allows you to do scripting. Because then you can put the notifications function here, for example, which remember is going to be the function that allows you to add functionality to the class hierarchy. So all the other functionality from the notifications of the class hierarchy is still going to run. You're just going to put another notification, and then you're going to select inside of the notification, we're going to have the switch statement that determines, for example, on the physics part of the process, you're just going to send the event as the physics part. So we put the switch statement there. And then inside of that case, on the switch statement, you would put the functionality that you wanted to run, the extra functionality you wanted to run on that part of the cycle. And this would change the behavior of the class. So it's the same as doing scripting functionality. You can do this, or you could subscribe signals as well from code here, which is different because the signals are related to the object instances, not the class hierarchy. But it's also another way to add the different scripting functionality. But the reason why it's different from GD extension is because GD extension is more of a composition approach. Because GD extensions work in the same way, or in a similar way that GD script works, which is going to be a member variable of the object class. So what that means is that on modules, you're using inheritance. So you're creating a new class to add the functionality to the class hierarchy. And when you're using GD extension or GD scripts, you're creating a member variable that is part of the class, object class, to extend the functionality in that way. And this is composition, where module is object-oriented. And the difference between them, this part I'm still not 100% sure, but the difference is that when you're using the composition, what that means is that this class here and the script instance class are gonna have to be designed in a generic way. So they're gonna use abstract-based class programming to create virtual functions that allow you to. So they're creating a base class to work as a bridge between all the different languages you want to implement, and then you're gonna change the functionality of what happens during the signals based on how each one of these classes implements the virtual function from the base class, which works as an interface between the object class and the scripting class through this bridge, which is the member class here. That's composition. So it scales different than object-oriented programming. Because object-oriented, you're going more like vertical, and composition is like you're going horizontal. So like composition is more flexible, and I think scales better for something like scripting. But it's not that bad to use object-oriented, I think. So both are fine. It depends on how much variance that you want each object of the visualization you're doing to have. And if the other downside I think that composition has is that maybe it forces you to use more memory because you're going to have to create more resources to keep track of all the things. But I'm not 100% sure about that because obviously class inheritance, you have to create another class as well. So I'm not 100% sure. But basically the main thing to take away is that the gradient is from object-oriented programming and composition. Object-oriented programming is very rigid, and so you can think about it as ice. And composition would be more like gas or water. So is a gradient of volatility. And the variance of the data determines is going to be usually a funnel and determines which way is most likely to be correct. So the reason why for something like scripting is more likely for composition to be correct, and the reason why people use Python and other languages for doing this kinds of things is because those kinds of languages and the composition approach, they allow you to they work better for more high variance environments. That's why they are dynamic programming languages. So yeah, so usually when scripting, the behavior of things are going to change more often. I think that's the reason why usually people prefer to use scripting languages for these kinds of things, like Python and these other languages, instead of using C++. But I'm not 100% sure. So now I think I've explained all this stuff. The most important part is the macros to understand there. So the notification is going to call the function from the macro that is declared on the GD, declared on the class there, on the GD class macro here. So the notification is a function that recursively calls all the notifications for the class hierarchy. And the difference between that and the signals, I'm going to explain signals now. Signals are more for when you have two instances of objects that want to communicate with each other. So you can imagine that on the scene tree, you're going to have different object instances. And each one of these object instances has its own class hierarchy. That was the part that was confusing to me first. So I was confusing the class hierarchy with the object instance. So signals is when you want to two different objects to communicate with each other. And notification is when you want the class hierarchy to have extra functionality. So basically the way that the signal is going to work, and it is kind of confusing. Obviously I'm explaining from source code, so yeah. So I'm going to close this stuff now because I think it's hopefully well explained. And then I'm going to open the signal functionality. So I have two main functions on signals. One is the connect function, which allows you to connect a class to a signal. So first you have the add signal. The add signal is just related to the class DB. So if you don't add the signal to the class DB, Godot is not going to understand that the class has the signal, because the class DB is the main class that is used to keep track of everything that is going on. So you need to first subscribe the signals with the add signal macro to class DB. But then after you do that, you can call this function, which is called connect, which is basically, the way you think about it is that both the two different functions have to be related to the same object. So when you call connect, it's going to allow you to implement some functionality that is going to run whenever the same object calls the emit signal. So the function that connects to a signal has to be the same that emits, as far as I understand right now. So in this case here, if this node here, for example, connects to a signal, then this node here can't emit the signal because this node hasn't subscribed to the signal. So it's always the same signal that connects, the same node that connects and emits signals. And the purpose of that is that it allows you to put some functionality from another class to run whenever the node emits the signal. So the main thing that is doing is connecting functionality from another node with the node that is going to emit the signal. So the way to think about it is that connect and emit are coupled with each other. And the thing that is external is the function that is going to run, which is usually going to be from another class. So in this case, for example, timeline would connect, timeline's connecting to the zone changed signal, and then is subscribing this function, which comes from the other class here. And what this is going to do is that eventually timeline is going to emit the signal, which is going to be this one. And when it does that, it's going to call the function from the other class, which is zone changed. So I drew this thing here to make it even more simple. So in this case, so there's two main cases where you are going to do, like the way that it's going to work. One is, and they're all from parent. So basically, the main thing to understand is that there needs to be a direct chain of connection between the function you want to run and the signal you're going to emit, because they come from different objects, but these different objects need to be directly linked with each other. And I'm going to explain some other stuff, but the main relationship is this two here. So in this case, you call a child function when the parent receives an event. So the parent connects to the signal and subscribes a child function to run whenever the parent's going to emit the signal. So here's somewhere along the code, you would emit the signal, and then once the signal runs, the child does some functionality. So I'm not really sure about a good example of this. Like, let's say you have a graph node, and every time you click a button on the graph, or let's say you have a control node, which is a UI element, and every time you click a button, you want the child of the node to change a value, for example. That's the case. So you would subscribe the event on the button, the signal on the button, and then you would emit the signal once the button is clicked, and then the functionality on the child would run, which would make it change its value. And the other relationship is the other way around, where you call the parent function when the child receives an event. And the way you would do this is by calling connect on the child and then subscribing the function of the parent. And then somewhere the child emits the event and the parent runs the function. So what's very clear here, and I think I'm pretty sure that that's how it works, but I could be wrong, so take this with a grain of salt. But what the main thing to understand here is that you need to have a direct connection between child and parent. Otherwise, you wouldn't have the reference here at the moment you call this to connect the two, which is one of the biggest problems that I found so far about signals, is that you need this direct relationship. So the problem comes when you have a sibling node or a node that is disconnected from the other node, and then you have two different alternatives, which is this case here, which is the exact same thing that happens on React. So React, you have the exact same pattern, and I think this is a fundamental pattern of programming. So React, you need context to send information from, so let's say, for example, we have this node here, and I have this node here. So if you want to send a signal, connect these two nodes, so subscribe a signal here, so when you emit an event, you call a function here. Because they are disconnected from the tree, you have two options. One is you use the lowest common denominator between the two, which in this case would be graph node, to connect the functionality between the two. So you would use the reference of the graph node from this one, because most likely you're going to have that reference when you initialize this node here. You're going to have the reference of this, which you're going to have the reference of this. So you would subscribe the function here, and then you would use this function that is here to manage the flow of data between the two nodes. So this is going to, we would emit a signal to this one, which would call this function, which would then call functionality from this node here. Which is also another thing that React has, because in React, everything, all these nodes here are a component. React is a tree, pretty much, and all the nodes are components, and the same thing happens. And the way that React transfers information is through the function arguments. And the name of this, when this happens, is called prop drilling, because drilling, because the more information you need to pass from this node to this node here, the more stuff you would need to have. So this function would get bigger and bigger. And on React's case, it passes data top down. So it passes from this node to this node. So what ends up happening is that eventually this node here is going to be overflooded with a bunch of arguments, because it has to receive a bunch of information that is coming from the other nodes, for example. So in order to avoid that, React, and I think this is a fundamental pattern, React created a global object called context. So this is the second alternative. So in this case, we would have another node here separate from the tree. And this node here would be the one that manages the information between them. So it's basically a global object. So instead of routing the information from this node to this node through this path here, you would just subscribe the information to the global object, and then the global object would be the one that emits the signal here. So it allows a lot more flexibility, but also increases the chances that something is going to go wrong, because it becomes more complex and confusing to keep track of how everything is connected. So this brings me to, I think, a realization that I had, which I think is the main fundamental pattern of programming and is an archetype and it's probably going to show up everywhere, which is that a tree is just a graph. So all trees are partial graphs, and every time that you have a situation where the data flow that is going through the tree reaches a certain limit, what's going to happen is you're going to be forced to use global objects because that's the optimal strategy. And what's actually happening is you're just converting the tree into a graph through the global objects. So it works as a bridge. And that's exactly the same relationship that the stack has with the heap, because the stack is just a tree. And the reason why it's a tree is because the movement of push and down over time creates a frequency, and that frequency is a tree data structure. So whenever something can't be put on the stack because the threshold of data reaches the limit, you're going to use the heap, which is an external global object. And then you create this connection between the two. And the flow between these two things is going to always converge or diverge, depending on the way you're thinking, to a graph data structure, because everything is a graph. So the reason why the tree is used is because of scope. So it allows you to limit the data to a scope, and then there's always this relationship between them. So on Godot, and this I'm not really sure, but I think I'm gonna try to do this. In order to implement global signals, what I think I'm gonna try to do is to use the same patterns that they use on ClassDB to keep track of all the classes, but use that for signals instead. And that way you would create a global store where events can be routed through that store from one node to the other. So it's pretty much the same pattern as React has. So I think that's pretty much it that I wanted to explain. Just thinking about whether or not I missed something. I think that's pretty much it. So there's some questions here I'm going to answer. I'm going to see these questions, and then I'm going to stop streaming, and then maybe I'll come back to I'm not really sure if I'm going to, depends on how difficult it is, but I'm going to see if I can implement the global signals. I want to offer blah, blah, blah. This is a bot. Is there a package registry the pros uses? I've seen a couple, but not clear winner, like npm. No, the main thing that is used on C++ to build stuff is CMake. And CMake comes from make, and it's just a build system. So CMake is cross-platform make, and it's basically a language. So you use a file called cmakelist.txt, which allows you to put some code on that is created by CMake that allows you to link different libraries and compile C++ files and include header files as well. So it's basically the main one that is used is CMake, and Godot uses scones, which is a Python build system. So this scones uses a Python class which is gonna manage everything that happens during the execution of the sconstruct file that can implement a bunch of other Python files. And I'm not 100% sure, but I think at the end what it does is just creates a giant command with all the stuff you need to compile all the C++ files and all the header files in the order that you need, and also link shared libraries and static libraries and stuff like that. So all this stuff at the end of the day is going to be like a command that you would run with make, and then make is a program that is going to compile everything. So the way that it works on C++ is first you can have macros on files, and then these macros, which is this stuff here that shows up after this hashtag operator. The first step is C++ is going to copy paste whatever code you have on this path, for example, on this file here. This is called preprocessing, and then it's going to look for the dependencies that this C++ file has, and it's going to link the C++ files with C++ file with all the header files that it needs, and that's called a translation unit. And then after it does that, it has something called an object file. And then the other step is the linking process, which is going to take these different translation units, which is the C++ file with the header dependencies that I have, and then it's going to connect them with each other. And then after it does that, then it creates the executable from that point, as far as I understand. Confusing for me how the C++ community works in that sense. Source from Git and glue it with CMake, is that it? Yes. You can also use Conan. Conan is another package management system, but there isn't a standard way to do that. And Conan can be kind of complicated. You basically create a JSON file, and then it's going to do like a bunch of requests under the hood to download the packages on real time. And CMake also has fetch, declare, that you can use is a function inside of CMake. It's also going to do the same thing. It's just going to download the file from the internet. But that's kind of more risky because then you don't have access to the code. Like, depend on the internet access. So what usually I prefer to do on the other projects is just download the source code from all the files and then create CMake files. And then most projects have CMake files on their own. And then you can use add subdirectory to just add the directory, or to put the directory of the project that has the CMake file, CMake list text file. And then you're basically nesting different build systems. But it's very annoying. And Godot uses scones, which uses Python, and then Python just creates the giant command based on all the different configurations, what kind of compiler you're going to use. So it takes the commands you pass here and allows you to put logic into them, and then at some point it merges those commands with the commands you can use for scones as well. But I don't understand very well yet. But it's basically using Python to build a giant string, which is going to run the command line. It's just going to compile all the files using make probably. Yes, I've learned Rust, and Rust's build system is a lot easier. Just use cargo, and then it builds everything for you. And then you have another file on cargo there that you can put on the project to specify dependencies. But all of the systems are doing the same thing under the hood. It's just the higher level or different languages, they abstract away some information and allows you to do everything. But because C++ doesn't have a standard, it becomes a lot more complex. So I'm going to stop streaming here because I wanted to explain all this stuff and then just stop so it's short. But I might come back today, after some time now, to try to create the global signals to implement here, because I think I'm going to need on the other stuff. And I don't like the idea of passing the information from one node to the other through the root. So I think it's better to create a global thing. But then it becomes a giant problem because of the... I could explain the callable there, but I think it's just going to be too much time. So maybe I'll explain, maybe I'll do another stream to explain that as well. But yeah. So the challenge is going to be figuring out the types and that kind of stuff. So yeah, so maybe see you soon today to work on this. If not, I'm going to work off stream, and then I'm going to continue to follow the steps that I have here on this file next.